Welcome everyone to the Our Warming Planet webinar series. Thank you for joining us today. Let's give everyone a few more minutes and we can get started. Thank you. Welcome everyone. We'll get started in a minute. Thank you for joining us today. Thank you everyone once again for joining the Our Warming Planet Climate Change Impacts and Adaptation webinar series. This is our 14th bi-weekly webinar, which started with a book launch in February. So thank you so much for sticking with us from the start of this year. And today we have a wonderful speaker, Carlos Nobre. And we are also excited to announce that we will have the grand finale on November 2nd. So please do sign up for that. We will share the registration link in the chat as well. And now I invite Cynthia Rosenzweig to get us started. Over to you, Cynthia.
Thank you, Vanishka, and welcome to everyone to the 14th webinar based on the book that you're going to be hearing more about, Our Warming Planet. Our agenda for our webinar today is an introduction section with David Rind and Manishka Demel. Then Carlos Nobre and will present the work of that he did with his co-author Ailton Fabricio-Neto on the Amazon forest and climate change, a sustainable pathway to avoid a tipping point. Then Jen Evans will conduct the live Q&A session, and then David and Manishka and I will do a wrap up. So that's our agenda for the next hour. And to share a bit more about the book that the webinar series is based on, here are my co-editors. First of all, the book is really a virtual honorific for Martin Parry, who is visiting professor at the Center of Environmental Policy at Imperial College London, best known for being co-chair of the IPCC Working Group 2 for the 4th assessment report. And so all this group of authors and speakers in the webinar series gathered to present really the field of impacts and adaptation in honor of Martin. Thanks also so much to the third editor of the book and the leader of the webinar series, Manishka Demel, who is Senior Staff Associate at our Earth Institute and Columbia Climate School, based at NASA Goddard Institute for Space Studies. She leads our portfolio of research in conservation and development. Then let me introduce the overall series editor, I think on the next slide, who is David Rind, Senior NASA Climate Researcher Emeritus at NASA GISS, and a climate research scientist for more than 30 years. So David, over to you. David is the series editor that the Impacts and Adaptation volume is part of. So David, over to you to tell about the books and what's special about them. Thank you.
Thanks, Cynthia. Being a series editor implies there is a series. And as Cynthia mentioned, this is the second book. The first book had to do with topics in climate dynamics. And in that sense, it's more oriented with IPCC Working Group 1. Obviously, our warming planet, climate change impacts and adaptation is more associated with IPCC Working Group 2. And there will be another book in the series coming out actually this month, studies of cloud convection and precipitation processes from remote sensing. And so that's sort of more like a Working Group 1 thing as well. What's special about these books is that they're meant for teachers and students and just people wanting to give talks or inform themselves about climate change. They have about 20 to 25 chapters in each book. Each book consists of about 5 pages of text and then about 20 PowerPoint slides. And the 20 PowerPoint slides can be downloaded and then utilized again in classes or in any sort of situation in which one wants to get the information across. The way the seminar series fits in is that in addition to having those slides and the article, you then get to hear the authors discussing the slides from their sort of expert professional point of view. So it gives a complete well-rounded aspect to the information provided. As indicated here in this next slide, these are the various topics and authors. And as we know, the talk today will concern the Amazon rainforest, a very instrumental component to our climate system and whose survival is so important. And this will be by Carlos Nobre. Back to you, Cynthia, or to Manishka?
We now go to Manishka to lead our getting to know the audience part.
Thank you, Cynthia. Hello, everyone. This is an opportunity for us to get to know all of you who have joined us today. So I have a poll with 3 questions, and let's get started. So the first question, as you'll see on the screen, and please poll, is which geographical region are you joining us from? So please participate, and we'll give it about 20 to 30 seconds, and then until most participants have voted, and then we can share the results with all of you. So we have over 80% of the participants who have polled, which is fantastic. So I am going to share the results. So today we have a large group from North America, but we also have participants from Asia, but it's quite late, so that's great, and also from Europe, Latin America, and the Caribbean. And then I want to understand a little bit more about which sector you work in. And we usually have a fantastic representation across all sectors. And I see that even today we have very good representation across all sectors, which is fantastic. So we have about 2/3 of the audience that have participated. So we'll just give it another 10 or 20 seconds more, and then I'll share the results. Okay, let's have a few more of you voting, and then I'll share the results. This is fantastic. We have all sectors represented, which is really fantastic. And then the final question is your involvement in climate change work. We typically have a range here as well. So we have about a little more than half now. We're towards 2/3, and we have great audience engagement, which is always good to see. Just give it a few more seconds. So if you haven't voted yet, please do. And then I can share the results. So we have about 80% who participated. So once again, it's just really great to see that there's a whole range of people who joined us today. So welcome and thanks so much. Great. So, we now got to know you as a group, but we would also like you to start introducing yourselves in the chat. You can share as much or as little information as you like. So you can include your name, country, institution, role, email, how you think this book might be helpful to you. We are curious to know that. And please use the chat function for this. And now I invite Cynthia to introduce Carlos. Over to you, Cynthia.
It gives me such great pleasure to introduce Carlos Nobre. It seems like we've known each other forever, Carlos. I want to start, before sharing all the many important projects that Carlos has led, not just accomplished, but led. I just want to start by saying, in my mind, and I think to everyone's mind, Carlos is the leading climate change scientist from Brazil, and it's a real honor that you participated in the Our Warming Planet volume and are here with us today. He is a senior researcher with the Institute of Advanced Studies at University of Sao Paulo. His PhD is from Massachusetts Institute of Technology, MIT, in the United States. He has dedicated his scientific career mostly to the study of the Amazon, as David Rind indicated, an absolutely critical component in the Earth's climate system. And has done a tremendous amount of work at the National Institutes of the Amazon Research and Space Research, INPE, known as INPE. And he was a program scientist for the large-scale biosphere-atmosphere experiment in Amazonia, the LBA. I believe that was a NASA large-scale bringing a large-scale project, bringing together on-the-ground research and then satellite research, satellite data as well. He's served in the Brazilian government, and he is a member of the Brazilian Academy of Science, of the World Academy of Science, and finally a member as well of the US National Academy of Sciences. His co-author, Ailton Fabricio-Neto, works with Carlos. He graduated in ecology from Sao Paulo. And to end the introduction, I just want to say, Carlos, again, just how much the world is so grateful for your scientific contributions to the challenges that the Amazon and the world faces consequently, that you have really contributed. Thank you so much. Over to you for your talk.
Thank you very much, Cynthia, David, and Manishka. And it's a great pleasure to be part of this beautiful effort. I really like Martin Perry. You know, I met Martin Perry at IASA in Austria in 1985. So I was 3 years after my PhD at MIT, and he invited us to contribute to a book that he published in 1985. So really, Martin Perry is a great name, a great scientist, and I feel honored to be part of this beautiful book. So let me share the screen here. So I will talk about the title of the chapter, the Amazon Forest and Climate Change and a Sustainable Pathway to Avoid a Tipping Point. I call it Amazon Green Deal. And I just want to say that, of course, as Cynthia introduced me, I'm a Earth system scientist, a climate scientist. But now, in the last 4 years, I'm switching a little bit in working towards solution space. So I'll talk a little bit about the project we are developing on the solution space to avoid the tipping point. And, you know, I've been working for more than 4 years in the Amazon-related science. I lived in the Amazon in the beginning of my career. And really, if you do not know the tropical forest, I strongly suggest you to go, because it's a beautiful place, beautiful rainfall systems, flora, fauna, and the rivers, the largest rivers on the planet, and the combination of the terrestrial and aquatic ecosystems. So, you know, I really recommend all of you come to the Amazon one day. So basically, I will cover in these 30 minutes, I will cover these 4 topics. Let me start with showing the importance of the Amazon as a regional entity of the Earth system. In the 1970s, the Amazon was seen as green hell. You know, I show here 4 books calling the Amazon green hell. That was really the idea in that era. Too mysterious, too dangerous. But in fact, the indigenous populations, they arrived in South America 12,000 years ago. They've been living in the Amazon for that time. And always they considered the Amazon as a green paradise for all the indigenous people. When the Europeans came, there were 8 to 10 million people, indigenous people living in the Amazon, over 1,000 ethnic groups. Now they are about 400 and much less, 2.2 million indigenous people. But they consider the Amazon as a green paradise. But let's look what 40 years, at least 40 years of science has shown in terms of how important the Amazon is for the Earth system. Is a key player in global carbon cycle, absorbs 15% of net primary productivity, and also stores more than 100 billion tons of carbon, 15% of fresh water, 210 cubic meters per second, the Amazon River, the largest place with biodiversity, more than 13% of biodiversity, animal and plants, 16,000 species of trees. Also very important for climate stabilization, water recycle. Very efficient water recycling for the forest, between 2 and 3 meters of rainfall a year. And of course, helps to maintain cultural and ethnic diversity. As I mentioned, we have over 400 indigenous groups in the Amazon and tremendous language diversity. So I think, you know, a key conclusion of science today is really the Amazon is a green paradise for planet Earth. It's not a green hell, it's a green paradise. And we have to maintain the forest. So in summary, we may say the Amazon rainforest only exists because the forest exists. It's not only a biological system responding to meteorological systems that would generate a lot of rain. Of course, it's a non-linear interaction between the surface, the forest, and the atmosphere. So it's a key evolutionary accomplishment, very high plant and animal biodiversity, very efficient recycling of water, very efficient recycling of nutrients. Most of the 84% of the Amazon soil is very, very nutrient poor because of heavy rainfall for millions and millions of years. And then this critical level of plant and animal and microfauna biodiversity to recycle nutrients. Most nutrients are in the forest, not in the soil. And of course, a very wet biome blocking fire spread. Over tens of millions of years, the tropical forest did not evolve with fires, without fires. Lightning strike ignited fires do not propagate because the forest is very wet. So basically, some of the services to the earth, carbon storage and sink, And also a lot of air is exported outside of the basin, what we call flying rivers. So for the carbon cycle, the importance of equilibrium below and above the ground, the Amazon stores more than 150 billion tons of carbon, even with the levels of deforestation, but still stores. And also the Amazon forest removed a lot of carbon. Unfortunately, now it's removing less, but it got to more than 2 billion tons of carbon dioxide in the atmosphere in 1990s, about 20 years ago. So this evolution, really, I could spend 1 hour just explaining in full detail this slide, but just to say, this is an evolution over tens of millions of years in which a few trees have very deep roots, and during the wet season, there's a lot of rain, so the rain percolates, goes deep, like 5, 6, 7, 10 meters depth. So some of those rooting systems, they pump the water, and they distribute the water near the surface, near the soil surface. So the other trees really benefit from that water. And then they take the water, of course, to the leaves, and there is transpiration year-round, very intense transpiration year-round. So this transpiration moistens the surface air, makes it more unstable, goes up and becomes rainfall, becomes clouds. The forest emits a tremendous amount of volatile organic compounds. They have photochemical reactions and become the cloud condensation nuclei. Very efficient system that evolved over millions and millions of years. So basically, 30% in parts of the Amazon, up to 40% of the rain really is direct related to this recycling, given the very high rates of evaporation. And also about 70% of the net radiation, let's say the solar radiation, the net radiation, goes to evaporation, transpiration. Only 20–25% is sensible heating to heat the atmosphere. That's why the top temperature in the tropics, equatorial tropics, is 30 degrees, so much less. And of course, there is this other effect. The trade winds bring a lot of moisture, so there is this recycling. One molecule of water vapor recycles 5 to 8 times rain, evapotranspiration, rain again, recycling, and exits the southern portion, also the Andes. A little bit goes also to Colombia. This is 50% of this water vapor entering the basin. 50% goes out in the streams, Amazon River discharge. 50% feeds rainfall systems south of the Amazon and also the snow in the Andes. So this is a tremendous environmental service for all of South America. And also the Amazon has the largest biodiversity, as I mentioned, 13% of all known plant and animal species, and a tremendous diversity of vegetable species. For instance, trees, angiosperm, tree species, 1 hectare has about 350 different species. This is more than all of European continent have of angiosperm tree species. One big tree in the Amazon holds about 2,000 species of ants. This is more than all species of ants in the United Kingdom. Just to give you a comparison how biodiversity exploded in all tropical forests, and particularly in the Amazon. However, we are seeing a tremendous deforestation, forest degradation. The development model installed in the Amazon in the 1970s is one without the forest, with fire generating tremendous air pollution. So basically, the development model that governments, the military government in the 1970s in Brazil, they practice this for 50 years now, trees as obstacle to the quote-unquote development, and burn trees as fertilizer for pasture. As I mentioned, very poor soil nutrition in the Amazon, so they had to burn the trees to have for a few years nutrients released for pastures. So this is the model. I just showed this paint. This is 1843 for the Atlantic rainforest, and you see deforestation at that time for cattle, for coffee plantations, and it's surprising that we see very similar. This 2019 forest picture. This is just to show, unfortunately, we went back to development pathways of 19th century here in the Atlantic forest, in the US, in the Wild West, very similar quote-unquote development models of 19th century, but still prevailing in the tropical forests. So the military government, they had this motto of that time that was the occupation of the Amazon will follow the cat's footsteps. So cattle was the vector for deforestation. So this is the cover of Time magazine in September '89, showing this torching of the Amazon. Can the rainforest be saved? On the left-hand side, this is the first satellite-based monitoring of the Amazon by the institute I worked for, INPE. Over 20,000 square kilometers of forest clear in 1988 in Brazilian Amazon, almost that in 1989. So this is the trend. Unfortunately, the trend continues. You see this picture, this is Washington Post a few months ago, cycle of fire and beef. So you see here, this is the left is areas deforested, right areas with pasture. 90% of the first deforestation in the Amazon is for a cattle ranch. And so basically US was not importing meat from Brazil for food safety concerns, but now 2 years ago start importing, and the second largest buyer of beef from the Amazon. China is the first one. So I'm just saying, unfortunately, that developed model continues. And that developed model is very associated with the infrastructure construction, roads. This is just to show you, as once roads are constructed, deforestation explodes. 95% of all deforestation in the Amazon falls within 5.5 kilometers on each side of all roads. So this is a deforestation for all of the Amazon. You see here, Southern Amazon, most of the deforestation, but also around the Andes, there is also an arc of deforestation, an arc in the Southern Amazon and another arc around the Andes. So 18% of the forest has been cleared. And unfortunately, in addition to clear cutting to replace by pasture and crops, we are seeing more and more forest degradation now. Let's say the one starts with selective logging. You can see here patios of selective logging, the tracks for the tractors and the transport of timber. And then after a few years, you start seeing loss of under canopy, loss of canopy, and 15, 20 years later, you see degraded and the fire scars. So the fire, the primary forest is very resilient to fire, but not this degraded forest. So this is areas degraded. 17% of the Amazon forest has been degraded in several stages. So 35%, about 2.2 million square kilometers of the forest severely affected. So Amazon is near a tipping point. This is really a research I started. I spent 1 year in 1989, 1990, 1988, 89, at the University of Maryland, working with the NASA Goddard Space Flight Center in collaboration with former astronaut Pierre Sellers and Jagadish Shukla. And we published the first paper in 1990 and another one, this one, 1991, in which we look at, one is forest, 6 is savanna, tropical savanna. and we looked at if there is deforestation, would the forests be regrow, would regrow the forest back in all of the Amazon? And then we found out at that time with the current 1989 type of global atmospheric model, that all these areas with the 6 here, the climate would become too dry, too long dry season to maintain the forest. So it will be replaced by savanna. That's what I call the risks of savannization of the Amazon. So that was the first paper, the first 2 papers published about that, and then made me really get very concerned about that. Today, unfortunately, we are seeing the tipping point of Amazon savannization has already been activated. When we look at all the tipping elements of the planet, of Earth system, mostly associated with global warming, and I'm not going to describe them all, but just one, melting of the Iceland sea ice, the sea, ice sheets, and this fresh water is interfering with the Atlantic meridional overturning circulation, AMOC, and increasing the temperature here in the tropical North Atlantic, inducing much stronger hurricanes, as all of you know, including this Ian hurricane a few days ago. But also, this is inducing more frequent droughts. 2005, 2010, 2020, they were droughts in the Amazon associated with the warmer waters here, 2015-16 with El Nino. And then this is synergistically associated with regional deforestation, degradation, fires, less rainfall, hotter, longer dry season. So this tipping point has been activated. I just summarize here 20 or 40 years of research. Cynthia mentioned the LBA experiment that we started in 1999. It goes on even today. We install sites, 13 sites with towers to measure the interaction between the forest and the atmosphere for forests, also for degraded pastures. So I'm just summing it up, 40 years of research. The first one was, in fact, started in 1983 in the forests. Basically what undisturbed tropical forests being converted to degraded pasture, basically, we see the system in the forest is much stronger water recycling capacity. It transpires a lot of water, much more in the dry season. Very interesting. More water evapotranspiration in the dry season, 4 to 4.5 millimeters a day. That's why it helps maintaining rain in the dry season. As I mentioned, it's cooler, more humid air, maximum temperature 30. And as I said, stronger water recycling. When you replace, smoother surface has much less weaker water recycling, very dry during the dry season, 1.5 millimeters a day. It's much warmer, maximum temperature 35 degrees, the whole thing warmer, 1.5 to 3 degrees. Weaker recycling, less rain, and longer dry season. So this is well known with 40 years of observations. So now we are seeing this cycle, which is not a virtual, it's not a virtual cycle because it's right. It starts with 3 laws: less evaporation, evapotranspiration, decreased rainfall, longer dry season, less humidity, induces more fire, which leads to a lot of forest mortality. So this is already happening in large parts of the forest. So basically, deforestation, degradation, and fires, we had more than 150,000 square kilometers of areas of the forest being burned in the last 20 years. So basically, changes in the carbon cycle, change in hydrological cycle, that may lead to the tipping points. And also, of course, there is a tremendous risk of new infectious disease. The Amazon is one of the places where the largest number of microorganisms, viruses, bacteria, etc. And it's a big mystery why never a pandemic originated in the Amazon, but it could happen anytime. So basically, we have this concept of this, how close we are to the tipping point, in which the whole forest would become confined in the Western Amazon, perhaps 30%, and then the remaining 60 up to 70% will become this degraded, open canopy degraded ecosystems. That would mean more an emission, perhaps of more than 300 billion tons of carbon dioxide, making almost impossible to reach the Paris Agreement targets. So that might happen within 30 to 50 years if we exceed the tipping point. And many studies indicated if deforestation exceeds 20 to 25% and warming, global warming exceeds 2.5 degrees, we are going to reach the tipping point. So this is just an analysis showing how close we are. Dry season has increased about 5 weeks in Southern Amazon in the last 40 years, since 1979, 4 weeks in areas of forest, 5 weeks in areas with high deforestation. Also, is the Amazon a carbon source or sink? The primary forest is still a carbon sink. However, deforestation, degradation, wildfires in the last 5 years, the forest is a carbon source, considering the emissions by deforestation, degradation, and wildfires. And this study is very worrying because it shows in all these areas with the red is when the dry season is becoming lengthier, hotter, and drier. There is an increase in tree mortality of wet climate tree species. So we are seeing the tree mortality increasing in these vast areas in most of the Southern Amazon. And this other study published last year in Nature, I just want to show, just to make this green bar here. This green bar is how much the forest removes of carbon from the atmosphere. And you see in most of the Amazon is negative, it's removing. But in this Southern Amazon, the forest has become a carbon source. So this is very, very worrying. So basically, we may say animation here, what might happen between 30 and 50 years if we exceed the tipping point. So we are going to see the disappearance of the forest. It will remain mostly near the Andes because the rainfall there is between 3 and 5 meters. Even with a reduction of rainfall, there will be conditions for maintenance of the forest. So basically, Professor Lovejoy, unfortunately, passed away in the last Christmas, a great scientist in the Amazon. So basically, we made this warning in this paper in 2018 of the tipping point. Then we have really to seeking, and that's the new career I'm trying to develop. I'm not an engineer, etc., but I'm trying to develop, looking for innovative, sustainable pathways. Can we avoid the Amazon tipping point? And basically, we are seeing here deforestation rates in the Brazilian Amazon. We had a lowest rate in 2012, less than 5,000 square kilometers. Now we are more than 13,000, unfortunately, going up. If we continue in this red curve here, then it's a dystopic scenario, fragmentation, and then we are going to exceed the tipping point and lose the Amazon. Then we really have to go to the green path here, zero deforestation before 2030, utopic scenario, but we have to work very hard to reach. So basically, we do not need to clear any more forests. Out of this more than 1.2 million square kilometers clear cut, we have 63% in cattle ranches, 23% have been abandoned. There's some regrowth of the secondary forest, and 14% in crops and mining and urban expansion. So is it possible zero deforestation, forest, zero deforestation, forest degradation, wildfires in a new economic model? Let's look at two land use models for the Amazon. First is we call first way, emphasis on maintaining the forest, indigenous territories, protect areas, but this has been seen as obstacle by traditional agribusiness sectors. So this is 47% of the Amazon still in protected areas, indigenous territories. But then the second way we'll call it resource-intensive development over the forest that has happened over the last 50 years, mostly commodities, meat and soy. Is it necessary to get rid of the forest? So this is a video showing, this is in the Brazilian Amazon, you see this great deforestation. We have about 21% of the forest, 820,000 square kilometers already clear cut, and almost the same in several stages of degradation. However, I'm sorry, this is in Portuguese newspaper articles showing there is no relationship between this development model, deforestation, and human development. Human development index are the lowest in the Amazon counties, and also the Gini index, the income inequality, is among the highest, particularly in areas heavily deforested. So this is not the way to go. So basically, we have to ask what else to do. Of course, maintaining conservation, increasing the efficiency of commodity production. This is necessary, but not sufficient. So what else? Then Professor Lovejoy and myself, we also talk about solution spaces, zero deforestation degradation, forest restoration, and standing forest bioeconomy. So let me start briefly mentioning this, starting what to do to avoid the ecological and social tipping points. As I mentioned, stop deforestation, degradation, wildfires. Government commitment is very important because over 90% of deforestation degradation in all Amazonian countries is illegal, is controlled by organized crime. There has to be a very strong policy implementation. And then forest conservation, restoration. The degraded areas removed in secondary forests, they remove a lot of carbon, from 11 to 18 tons of carbon dioxide per year. And the secondary forest in the Amazon grows for about 30, 35 years, and even the primary forest removes between 1.8 and 3.6 tons. So it's very important. And that's why we are proposing, or going to launch during COP27 in Egypt, a project which is called looking at these two arcs of where most of the deforestation is in southern Amazon and around the Andes. We are proposing these arcs of restoration. So basically, we are proposing a big project which is restoring more than 1 million, more than 100 hectares of deforested and degraded forest. Totally possible, and that would remove between 1 and 1.5 billion tons of carbon for many decades, for more than 2 decades. Of course, needless to say how important that is for combating the climate emergency. We know for Paris Agreement targets 1.5 degrees, we have to, in the second half of this century, we have to be removing not less than 5 billion tons of carbon dioxide from the atmosphere. This is a big challenge. So restoring globally forests, particularly tropical forests, is essential. And this is a project we are going to launch during the COP, just to create the momentum for getting to zero deforestation and restoring large area. That's also important if we want to avoid the tipping point. So the other one is how to develop a new bioeconomy of health, standing forests and flowing rivers. This is a big challenge, but we want to find ways. So this is the Amazon Third Way Initiative, a sustainable development paradigm, which is really necessary. This is how to add value to the forest products. What's the potential of biodiversity-driven bioeconomy in the Amazon? So this is the idea of the project, how to bring this Industry 4.0 to harness the biological and biomimetic assets, the potential, and also how to merge that with the knowledge of indigenous people and local communities. This is a big challenge, but we are hoping to find solutions for that. What's more, what makes more sense, agroecological systems or the commodity traditional agricultural cattle and soy. So we know many examples in the tropics, particularly in the Amazon, of agroecological systems as secondary forests. They maintain about 60% of ecosystem service, biodiversity, and carbon. So this is very important. Just let me give you just a few comparisons here. Former cattle ranchers which moved to agroecological systems of cocoa. So they make 7 times more income compared. Cattle is very low productivity. This is a comparison, another study in 2 cities along the Trans-Amazon Highway. Medicilândia produces cocoa in agroecological systems, and Apuí produces cattle. It's meat, cattle ranches. Let me just show this slide. Just shows the size of the land holding. Red is big ranches, 400, 300, 400, and the green is the cocoa agroecological systems. And net income per hectare, much more net income in agroecological systems with cocoa. And of course, I think all of you know, acai berry became a very important product. Globally speaking, it was only an Amazonian product. In the last 20 years, exploded and generates a lot of products, more than 40 industrialized products of the acai berry, brings more than $1.2 billion to the Amazon economy, and produces something like 1 hectare of acai berry agroecological system, $1,000 compared to soy, 200. This is 2019. Soy price has increased, and the pasture cattle ranch is only $100. So this is the idea with the how to reconcile economic development and forest conservation. That's the idea of this initiative, Amazon Third Way initiative. So how to develop the social biodiversity bioeconomy, how to add value through industrialization in this bioeconomy. So this is the idea, a new bioeconomy, health, standing forest and flowing river, constructing industrialization, biofabrics, urban and rural, how to link social biodiversity, Amazonian people, science, and the knowledge of science, indigenous people, local communities, and innovative technologies. So this is the, let me show briefly a film. So this is the idea, technological innovations Industry 4.0, environmental conservation, and valorization of local cultural and ancestral knowledge of indigenous population, local communities. So I don't have the time to tell you all the initiatives, but we are having three components: creating an Amazon Institute of Technology, creating Amazonian Rainforest Business School, and Amazonian Creative Laboratories. We are developing, are going to bring a first laboratory to do capacity development and industrialization. So we really want to develop these innovation ecosystems, sustainable innovation ecosystems, how to win some valleys of death. The first one is talent pool, science and technology challenges. That's what we want to do with the Amazon Institute of Technology, the Rainforest Business School, and these laboratories that we're bringing to the Amazon. Basically, how to construct this ecosystem of innovation, sustainability, and business in the Amazon. We need really to change the way the economy of the Amazon has functioned for 50 years, but it's doable, it's possible. So basically, let me finish by looking ahead. What's the real advantage of biodiversity-rich countries, such as the Amazonian countries, in the concert of nations? Do we want to be only a primary economy, only commodities, beef, soy, gold, or we want to be providers added value products of the rich biodiversity and ample sharing of benefits? So basically, that's the idea of this Amazonia Third Way initiative. This implemented this standing forest, flowing rivers bioeconomy. It's a tropical bioeconomy. It's new, does not exist anywhere. So we have to create or to learn with indigenous people who have been having an economy of standing forest for thousands of years. So basically becoming environmental powers of the social biodiversity. So basically that's the vision for the present and future, is to keep, let's say, up to 70% of the forest with full protection, 15 to 20% sustainable forest management. This is standing forest, flowing rivers, bioeconomy, agroecological systems, and then only 10 to 15% intensive use is a regenerative agriculture, sustainable agriculture, mining, urban infrastructure. A big challenge is how to merge scientific and traditional knowledge, but has to be the basis for this sustainable development. Let me just say, a famous geographer from Federal University of Rio, Berta Becker, who left us a few years ago, she dedicated her whole life to the Amazon. She created this sentence that we inspired all of us to add value to the heart of the forest, and also indigenous leader Davi Kopenawa, saving the heart of Mother Earth. So this is the big challenge. So finalizing, I just want to say this is the idea of the Amazon Green Deal. Is a nature-based solutions that what we have to combat climate emergency, to protect biodiversity in the whole planet, but certainly in the Amazon, under this very, very serious risk of the tipping point. So how to transform the Amazon in the environmental power of social biodiversity, creating this new circular bioeconomy, health, standing, forest and flowing rivers, to create well-being, jobs, prosperity, protecting all the biodiversity, and also, very important, combating climate change. So basically, this is the living and sustainable vision for the Amazon. That's the vision we have to really implement, collaborating with all the Amazonian people. I just want to finish by showing, this is a newspaper, Brazilian newspaper by this famous journalist Miriam Leitão, published in the end of August. She went and interviewed these communities in the Amazon producing agroecological systems, like this one is cocoa producing, and then she interviewed this child, Maísa, and Maísa said, a 6-year-old child said, she wishes to become a woman practicing sustainable agriculture in the Amazon. So I think this is our big challenge. Let's really create the world for Maísa. Let's create a world for a child like Maísa. Let's say she's 6 years old. When she goes to the university 11, 12 years from now, that she will see another Amazon, a sustainable Amazon. So let's save the Amazon. Let's save the Amazonian people. This is the Amazon we want. Thank you. Thank you very much.
Thank you, Carlos. Thank you. I'm the designated applause, but I'm sure that everyone is. Thank you for that. Just so vitally important presentation, and that it's wonderful that you have turned to solutions from the base of the science, because that is where we need now. The world first needs now. We need the solution. The world needs solutions now, and I think we're all in our work doing that. Much more we've provided the science. Of course, we'll continue to do so, but we must have now the decade of climate action, the decade of sustainability, and decades from now into the future. So thank you so much. It's really just really a wonderful opportunity to hear your presentation. Jen, over to you there's been a very lively chat, Carlos.
Yes.
And also do want to say before, as Jen is just about to start, but just also want to say, you mentioned that you met Martin at YASA, and in the book, there's a picture of you, that project. It's on page, it's in the introduction. Figure 3 in my write-up about Martin's career. And you're there with Tim
Wonderful.
Carter and the other members of the project.
Thank you very much.
Jen, over to you.
Okay, so yeah, there was a very lively chat, and hopefully I can get to some of that, but I will start. There are lots of questions in the Q&A as well. So to start off, from Kirsten Path asks, how do we create direct economic incentives for people to preserve the rainforest instead of converting it to pasture?
Very briefly, I think, number one, economic incentives will be for all consumers in the world, in the Amazonian countries as well, but particularly the countries importing these commodities from the Amazon, mostly beef and grain. They practice sustainable, responsible consumption. One of the goals, sustainable development goals, really, because if the countries importing a lot of these, they really demand traceability, etc. Because, as I mentioned, more than 90% of the deforestation, degradation in the Amazon is all illegal, even against the legal framework of the Amazonian countries. So, traceability seems to be a very important element. The other one is, of course, is a change in the habits of the new generation, let's say greatest generation. I think many of the people watching these lectures of the book chapters, you are also youth. Why not to change? Let's say, instead of consuming meat like crazy, we eat meat like crazy. Eating too much meat is no good for our health. It's terrible for our health. So let's switch to a diversified food system that we would valorize a lot of these biodiversity products all over the world, but certainly from the tropics. So if we valorize agroecological systems, there are some cooperatives in the Amazon, they produce more than 100 products from the biodiversity of the Amazon forest. So acai berry, all of you know today. So we really, and cocoa and also Brazil nuts, but now really we have to valorize this standing forest bioeconomy. We have to create markets for all these products. So this is the challenge, and I would really place this challenge, particularly for the youth generation. Do not, go and do not buy anything that comes from the Amazon that there is no 100% traceability, to make sure it did not, has not driven more deforestation.
Thank you. Okay, and I think this next question actually goes off of that really well. So Stephen or Stefan Soifer asks, Carlos, would the Amazon Green Deal benefit from a system of credit co-ops that would allow small and medium landholders to survive in the face of the invasion by large corporations?
Yes, yes, we have to create this. The Amazon Green Deal is really to create this new environment. It's a sustainable, as I call it there, the innovation, sustainability, and business ecosystems that would benefit a lot of these small and medium size landholders. As I mentioned, the social economic benefit of this agroecological system is much better. There are some cooperatives in the Amazon in which 50% of the landholders, they became middle class. Of course, I mean, you have to understand, I mean, if you go to the US or Europe, almost 100% of the farmers are middle class. When you go to the Amazonian countries, 90% of the farmers are very poor. So we have to create a new economic systems that would bring social economic benefits to this 90%. So we really, if we create this innovation sustainability ecosystems for sustainable business, it will benefit a large number of the Amazonian countries' population. So this is the way to go. It's not easy, but that's really the only way we have to go. And then, of course, governments have to be very strict because, as I said, more than 90% of deforestation is illegal. So they have to enforce the law effectively because, yes, you can have a regenerative agriculture, regenerative livestock farming, that would mean that you might need 50% of the area under pastures to produce more meat than you produce today. So this we have, it's a big challenge, but we have to go in that direction.
Thank you. Okay, so these next two, I'm going to say two questions because they kind of are similar to each other. Thomas Brewer asks, at the upcoming COP, do you have an amount of money to ask from the rich country big emitters for compensation? And Fernando Borba says, are developed countries willing to pay the Amazon carbon sequestration?
Yes, this is a big question. It's not only for me. This is a big question. We could see it during COP26. Many developing countries saying, well, you know, the Green Climate Fund should be $700 billion a year, $1.3 trillion a year. They, you know, even the other funds, losses fund has not been created. And of course, as I mentioned, we are going to release during COP27 these large arcs of restoration project to restore more than 100 million hectares. That would cost more than $15 billion. And of course, we have to find, you know, the Amazonian countries have to find ways, particularly from the rich developed countries, to fund that. On the other hand, let's assume a big carbon credit market exists. And then people say a ton of carbon dioxide removed by the growth of the secondary forest is worth $30. Well, you mean at minimum 1 billion tons of carbon dioxide removed a year for more than 30 years. So you're talking about $30 billion. So if this carbon credit market eventually becomes a reality, which is very important in my opinion, to combat the climate emergency, then all in the planet, particularly in the tropical forests, forest restoration projects will have tremendous economic benefits. So I would say I fight very much for COP27, COP28, really to find the solution for creating this carbon credit market, global, reasonable. And then, of course, then the economy of the world would bring the money to fund these big restoration projects. So that's what I'm saying. But even to start a big arts of restoration project in the Amazon, we would need a support by developing nations, a support by the Green Climate Fund, and we are talking about tens of billions of dollars.
And so now looking at the chat, and Carlos, feel free, you can read it, but I'll try to summarize some of what people were saying. But wondering if you could clarify about the idea that there's still 60% of the forest left untouched, but it's 25% that will bring us over the tipping point. So just wondering if you could clarify on those percentages and what it means that still 60% remains untouched and not destroyed.
Yes, this is a good question. It's because, as I showed, this whole, 1/3 of the Amazon in southern Amazon, all the way from the Atlantic to Bolivia, it's at the edge of the cliff of the tipping point. As I mentioned, the dry season is 4 to 5 weeks lengthier. During the dry season, the temperature is 2 degrees warmer, 20–30% drier. Dry season is even drier. Tree mortality has increased tremendously. And so that's why we are, if that area becomes, remember what I said, the trees recycle very efficiently water, and they contribute in over Western Amazon, more than 40% of the rain depends on this recycling. So when you start deforesting this whole area in the southern Amazon, you reduce recycling in that area, but there will be less moisture being transported to the Western Amazon. So when you do that, that's why many studies have shown, although you may keep 60% of the Western, Northern Amazon as forest, but the southern is very near the tipping point. And if that tipping point is crossed, what happens is that it will become a degraded ecosystem with very little water recycling. During 6 months of the year, the dry season will last 6 months, very little water recycling. And that tipping point happening in the southern Amazon will extend to the northern and also to the central Amazon. That's why it will extend, because there will be much less water recycling, and also the temperature will increase. So this is what many studies have shown. Of course, the studies use climate models to answer that, but many studies are showing. And one recent study by the Exeter University in the UK have shown, looking at the greenness. It's a satellite monitoring for the greenness of all Amazon forest. It's showing the forest is losing greenness in central, eastern, and southern Amazon. So we are starting to see this, unfortunately, this interaction between the southern Amazon, highest deforested area, very close to the tipping point, and other portions of the Amazon. So this is something that we should really be concerned. And also, as I said, it's a synergistic combination of, let's say, exceeding 25% of deforestation and global warming, when global warming reaches 2.5 degrees, because with 1.1 degrees, as today 1.2 degrees, we are seeing much higher frequency of extreme droughts. If the global climate reaches 2.5 degrees, we are going to see much stronger droughts in the Amazon, all over the planet, but in the Amazon as well. So that's the synergistic combination: more frequent droughts, extreme droughts, with exceeding this 25% deforestation.
Great, thank you for that explanation. I think cleared things up from the chat. We have one more question that we have time for. So Leo Klee asks, what is Carlos's view on carbon offsets, in particular via reforestation? Is this an effective and valid instrument for companies to set off their Scope 3 carbon emissions?
Well, I think so. Of course, there is a, let's say, I follow that. There is a political sometimes even philosophical movements radically against carbon offsets. There are some movements, environmental groups, NGOs, etc. They say zero carbon offsets. The companies have to really to get to zero emissions. That there is no offset is good, but I don't think so. I think there is a transition. Of course, carbon offsets. Companies, let's say aviation has an agreement to start declining emissions, net emissions, but of course they cannot replace the fuels for aviation to biofuels or electric planes in a few years. So they will be a big buyer of carbon credits. So, but I think it makes sense because it will be a transition, because in the many sectors will, purchase the carbon credits to do the carbon offset. But of course, we have to be very rigorous in terms of making sure these companies, aviation, but particularly energy sector, will move towards net zero. So, but I think it will be important for the transition to have carbon offsets, at least for, let's say, 1 or 2 decades.
Okay, well, I think that's all the questions we have time for. I'll pass it over to Cynthia, David, and Manishka. And thanks again, Carlos, for such a harrowing but inspiring lecture.
Great.
Thank you
Yes,
very much.
well, yes, this is just the wrap up. This is the wrap up part. Carlos, want to thank you again. Wonderful to have this time together for you to really share the crucially important work that you've been doing, not for the whole 40 years, and then also working in the solution space and developing the solution spaces. And we wish you all the best for COP27 and the project of the arcs of restoration. I think it's brilliant and something that we very much hope the countries of the world will get behind to fund and to really begin to fund in Egypt. So with that, thanks to all participants. Please be sure to join us. We have, I think, 1 more regular webinar, and then we have our grand finale. Carlos will be inviting you to come back because we're bringing all the authors of the book. It's really a community of scientists and researchers who really together created the field of climate change impacts and adaptation and solutions. So with that, I'll turn over to David for a last few words, and then Manishka for the final wrap up.
I just wanted to comment on one of the last things that Carlos said, that to some extent, the future of the Amazon resides in a way outside the Amazon, with this comment that as the planet warms, droughts may become much more prevalent. The warmest time period we know from the paleoclimate record, the Mesozoic, when dinosaurs sort of had their biggest run and CO2 levels were higher, is known as the age of warmth and aridity. And throughout the tropics, there's evidence of great aridity during the Mesozoic. They can tell by the soils that were evident at the time. And so whatever is done in the Amazon, everybody doing things throughout the whole world are going to affect what's happening in the tropics, including the Amazon. And so we've got to get a broader community in to save the Amazon, not only for the sake of the Amazon, but for the sake of the tropics as a whole. Thank you.
Thank you, David. Thank you, Carlos, so much for your really wonderful lecture. It's always, a challenge to listen to the issues that we are facing, especially with with the Amazon. But I do have hope with all the wonderful projects and the solutions you're involved in. So all the best for that. And thank you, Jen, for moderating that really wonderful discussion. And thank you to the audience for being so engaged in our session today. Thanks, Cynthia and David as well. Always great to have all the editors on. As a reminder, we have one more regular webinar on October 19th. And then on November 2nd, we have the final lecture and the series wrap up, the grand finale. So please sign up for that. I have put the link in the chat. We have completed so many, about 20 lectures. They're all available for you to view. I have also shared that link. So feel free to catch up on any you have missed. The objective of the book and webinar series is to reach students, teachers, professionals, and all interested people across the world, especially in regions with limited resources. So please do share information about this webinar series with your networks, and we look forward to seeing you in a couple of weeks. Thanks so much, everyone. Have a great day.
Thank you.
Thank you, Manishka.
Thank you.
Thank you,
Bye.
Carlos.
Thank you.
Thank
Bye,
you.
everyone.
Bye-bye.
Thanks.